sleep. Okay, so let me conclude with meaningful data. It started with MFG Labs. And in fact, we didn't came with some tools in mathematics and went into big data. The big data problem jumped at us. Okay. So practical expertise and models mainly for big data involving people. Why I mentioned Havas Media, which bought our startup company and kept it as a startup company in the group. Because they really want the innovation to take place inside the group. Why? It's because advertisement is becoming entirely digital. Okay, so you cannot open an internet page without being plagued with ads. Behind these ads, there are real-time auctions to affect your cookies to particular ads. Okay. This is a completely new world with all kinds of participants and so on. And all this is about collecting all kinds of information, your cookies, for instance, and using them to sell the appropriate ads. It's not working very well because I'm sure that some of you have had the experience. You make an hotel reservation in a certain place on booking.com, for instance, and then for weeks you get ads about going to the place you already bought. Okay? And this is quite typical. So there is clearly lots to be made and so to tune the ads to the user. Okay? You have both Google and Facebook are organizing the selling of those ads. It's a completely new world which is changing marketing in an incredible way. Let me tell you our story, which is why we were, fortunately for our bank accounts, we were bought by Havas Media. So we created, you can go, you can register, so you go to Warner Bros. France, and you look into My Warner. Okay, so if you decide to go in with My Warner, you have to open to us your Facebook Connect. Okay, this is clear. And then we know what's going to be our taste and so on. So we collect the data. You get like free tickets, games, and so on. Trailers 2 weeks before the others. So that's how the incentive is being created. So we created all that. This was a multidisciplinary team involving people making the design of the website on which people register, creating the activities, the data collection, the data processing. And then at the end of 2 years of development, Warner Bros. Gave us 10 cases telling us, okay, those are things that we are selling. With the data you have, can you do better? So each case was one engineer working for a day, and we processed the 10 cases less than 2 weeks. They use it. Sales were multiplied by a factor that ranged from 2 to 10. Okay, proof of concept. I mean, everybody's talking about big data and using data. In fact, we proved through this example the commercial impact if you do it well. So what about to do it well? Well, it turns out what we claim is that it's very useful to involve these min-field games models. Think of social networks. We are essentially interested in situations where the data are being created by people. Okay. New models that include classical clustering models in machine learning like K-mini, M, and then algorithms. I want to emphasize that is that our characteristic is that there is no need for any kind of Euclidean structure or any kind of a priori distances. They pop up in a self-consistent way. That's the beauty of this Nash equilibria. Why people? Well, you may be aware that the New York City has released all the data about all taxis in New York City for years. So time of departure, time of arrival, and location of departure, location of arrival, and the type of the taxi, okay? Because they know there is a huge information not only about tariffication, possible tariffication, but also about the flows of people in the city, which is, of course, a question of tremendous importance to understand, you know, the flows. I mentioned Facebook and movies, the Warner Bros. Experience, and I want to mention that those ideas of distance, very naively, people would say, well, let's look at a cluster of friends, and that's going to be through the links between friends, that's going to be distances. But this is much more complicated than that. Because in fact, you know, some people may say, well, I liked Harry Potter 1. Some others may say, I liked Harry Potter 2. They are close. But if you just look at this with numbers, they are not close. So you have to understand, you have to learn that indeed they are close, because the people that say those things are close, and this has to be consistent. So this is not, you cannot set up a distance and say they are close because the distance is small. No. You have to learn it in a self-consistent way, and that's what is being done with Minfield Games. Almost over, is that even if for pure data models make sense, so although we are always dealing with data that comes from people, it makes sense when those data are just being collected, like financial data and so on. So the change of point of view is that you consider data points and you look at them as if they were agents, like virtual agents. So a little bit like in some sense I'm getting it. In the so-called Maxwell demon in electromagnetism. I found the name. So you know, at each data point you put a little demon that is going to interact with the others. And that's going to be how you may extract information. So in fact, lots of terminology has been in machine learning data analysis use words, expressions from game theory. Well, our claim is that one point of view, it's not the only one, one point of view is that there is indeed a deep connection. So classical came in just to give you an example. That's a classical, a very classical problem, and which yields all kinds of very efficient algorithms for clustering of data. It's the problem is that you have endpoints and you want to find k barycenters of those points. So basically you want to divide the whole crowd of points, like agents, in k clubs, k cities, to which city they want to ups. And so you want to create a partition, A1, AK, of this set of points. So you're going to belong to the ace class if this barycenter is the closest. So that's the distance. Here there's a distance. That's a classical machine learning problem. Yi minus xj has to be less than this. And then yi is a barycenter. Once you have found the class, it's self-consistent. You see, again, it's self-consistent. So this is a classical k-mean problem. Just to give you an example of the Minfield game interpretation, you introduce a global criterion. Very often it's just a minimization. So it's like putting some values of, I want to belong to a club or to another one. So what are the values for me of those various clubs? Okay, or the costs of the various clubs. And I will go to the club which has the lowest cost. Okay. So this is a general principle. It could be mean, the minimum of those guys. There are many, many variants. Then I have to build a criterion that builds those, how do I assign a certain value, a certain cost to being in one class or the others. And that's the type of densities that I want to create. So if F is the initial density of data, in fact, in what I'm going to describe, data could be discrete. It could be so large it's almost continuous. You don't see the difference. It's the same model. It's independent of the size. And then you solve this MFG model. Okay, I don't want to spend too much time on that. And if you look on the k-mean example, so you can find explicit example, and you find is the barycenter, is the objective function, which is just the Euclidean distance. So it's by this, I just want to say that there are all kinds of algorithms that exist in the literature, which exist in computer science, in machine learning, in statistics. And the point is that many of those have a very natural main field game interpretation. On top of that, when you have no distance, you can create lots of new problems, new models. No need for distance, no need for Euclidean structure, choose criterion, choose class criteria, and you do that. Transposition for graphs, and is trivial. Social networks, equilibria. This is really the type of feedbacks, the type of equilibrium I want to emphasize. So typically on Facebooks, you have distance on items like movies. You have distance on users. You are commenting on those movies. You have preferences, and all this has to be consistent. But you cannot give an Euclidean distance even in a high dimensional space, which is going to do the job. That doesn't work. So this is the connection between those kinds of monster equation in infinite dimension and very practical applications almost in everyday life. And that's a good example of what mathematics can do for you. You were mentioning, and I loved your query about the language which is most spoken on Earth. This is it might even be true, what you said, especially taking into account that mathematics is fortunately a language which is shared by all scientists and is not restricted to mathematicians. Mathematics belongs to everybody, not to mathematicians. Let's be clear. So with this final comment, I thank you very, very, very much for your patience.